In this video, we are going to simplify rational expressions. But before we simplify rational expressions with variables, let's do this with numbers. It's easy to understand. If I have 4 multiply 3 over 4 multiplied by 5, this can be written as 3 multiplied by 4 over 5 multiplied by 4, and all this can be written 3 over 5, 4 over 4, 4 over 4 is equal to 1, and all this is equal to 3 over 5. Of course, we are not going to do all this each time we want to simplify. So in practice, what we do, if we have product here, a common factor, like 4 for example, we just say divide numerator, denominator by 4. And then we are left with 3 over 5. Good. This is exactly what we are going to do, but with expressions. So when you have an expression like this, how do you proceed? First, you need to factor anything that can be factored. So let's go one by one. Negative 3x plus 2, nothing to factor here. 2x minus 2, we can factor the 2. So 2x, let's put it here on its own. Yeah, we can factor the 2 out and write it as x minus 1. 2 times x minus 1. Now let's review the factoring here. The factoring, it's the inverse, it's the reverse of the distribution, the rule of distribution. Now the rule of distribution is a multiplied by b plus c. It gives you ab plus ac. So if you go like this, you are distributing. If you go like this with the common factor a, you are factoring. This is exactly what we did here. 2x, 2 times x, and then 2 is 2 times 1, and then 2 is a common factor, and then we factor. Okay, maybe some of you, they know this already, but it's just a review. So we can factor this. Now here there is nothing to factor, and here there is nothing to factor. But when you compare this with this, what is the difference between them? It looks like the difference is a minus sign. So I will go and say my 3x plus 2, this expression here, I can write it with the minus 1 or just a minus 3x minus 2, and this is exactly what we have here. So it's like factoring negative 1 if you want. It's like factoring negative 1. Now let's go to our expression and start working on it. So now we are going to replace this by this. Okay, we know why. Yeah, so negative 1 or just minus 3x minus 2. Here x minus 1, nothing to simplify, multiplied 2x minus 2. 2x minus 2, we have seen it's 2 times x minus 1. Here 3x minus 2. Now of course we can go into the details and put them everything together. We just do it once just to show that it is it's the math behind all this. So I'm going to keep this with this. Yeah, this one I put it under it, and the other side 2x minus 1 I keep it there, and then here put x minus 1. Now what I did, I just interchanged these two because of the commutativity in math, in algebra. So I put this one here and this one here. Now this gives me 1 and then minus. Now this gives me 1. I'm left with 2. So this is negative 2 altogether, the final expression of the given expression in part A. Now, of course, in practice, you can just go here and say, okay, this simplify with this simplify with this, and then you will have the -2. But here we are showing the math behind all this, which is very important, because even if you forget, you just go to the basics and you can do it without even without having to remember anything. Just the basic math will help you go through it. We now simplify the expression in part B. So 2n plus 3, there is nothing to factor here. 3n plus 15, so let's work it out here. 3n plus 15, that's 3 times n plus 3 times 5. So we can factor the 3 out, n plus 5, good. N minus 5, that doesn't seem to be anything to factor here. And then 6n plus 9, 6 and 9, they've got a common factor, which is a 3. So 6n plus 9, 6 is 3 times 2 times n, that's all for the 6n, and then 9, it's a 3 times 3. So the common factor here is a 3, and we write it as a 3. Now here we are left with 2n, yeah? 2n plus 3. Good. Now let's go back to our expression and then factor out, substitute the expression we just factored. So 2n plus 3. Now 3n plus 15, here it is 3 times n plus 5. So yeah, let's take this out first. 3 times n plus 5, and then n minus 5 stays as it is. 6n plus 9, we said we factored it here, so it's 3 times 2n plus 3. Now we are not going to go all through the details, we just go and divide by whatever we can. So I'm going to divide this numerator by 2n plus 3, and this denominator by 2n plus 3, which means take this out. This is n plus 5, n minus 5, it's not the same thing, so we cannot simplify here. Now 3 and the 3, they go, and then we are left with n plus 5 divided by n minus 5. This is the final expression to part B. Let's now go to part C. Now in part C we have got the numerator 2x2 plus x, and we try to factor here. Now 2x2 is 2 multiply x, and then plus x here. So there is a common factor, which is the x. If we take it outside, we will be left with 2x here, and here x is x multiplied by 1, so we will be left with 1 here. Can we check? Let's check. X by 2x give me 2x2. X multiplied by 1 gives me my x. Always check when you factor, and when you can, of course. So let's go to the expression, and now in the denominator there is nothing to factor, it's already factored. So we just go to the numerator and substitute the expression by the factored 1 to x plus 1, and then here you have x and 2x plus 1. Divide numerator and denominator by x, divide numerator and denominator by 2x plus 1, so all this gives me 1. Now let's go to part C. Now we notice that in the denominator we have got a trinomial. It's a polynomial of degree 2. Now these are factored by selecting terms of the form x plus k, x plus m. And m and k are constant numbers to be determined. Now how do we do this? If we go here and we multiply x by x, that gives me my x2, which is here. If I multiply x by m, that gives me a xm. Let me write it as mx. And then when I multiply this, that gives me kx. And then when I multiply this, that gives me km. Now mx, kx. Let's put x as a factor and we are left with m plus k. Now we compare this with this. x2, x2, no problem. The coefficient of 2x is 2. For this polynomial and this one here to be equal, the corresponding coefficient must be equal. So x2, x2, no problem. The coefficient is 1. Here the coefficient is 2. Here it's m plus k. The constant term here, it's negative 3. The constant term here, it's k multiplied by m, or m multiplied by k. So how are we going to find this m and k? We're going to do this by guessing. So what we're going to do, find two numbers. When you multiply them, they give you negative 3. When you add them, they give you 2. And then you start thinking, and the terms can be 1, 3. So for example, negative 1 multiplied by 3, that gives you negative 3, or 1 and negative 3. So this is the product. Both of them, they check the product. Do both of them check the sum? Let's see. Negative 1 plus 3 gives me 2, but this one doesn't give me 2. So the solution is this. And I can take m equal negative 1, k equal 3. Go back to my factoring here and say that x2 plus 2x minus 3, and it's x plus m plus minus 1, that gives me minus 1, and here x plus 3. And always when you factor, you check. Let's check. X multiply x, that gives me my x2. X multiplied by 3x, x multiplied by 3, that gives me plus 3x. And then this gives me minus x, that gives me my 2x, good. And then negative 1 by 3 gives me negative 3. Everything seems to be good. Let's go to our expression and substitute the numerator by x minus 1 multiply x plus 3. This is what we did, we factored. Now in the denominator, x plus 3 cannot be factored anymore, but 2x minus 2 can be written as 2x minus 1. Now we start simplifying, looking for the common term. The common term, x1, x minus 1 here, x minus 1 here. When you divide, they give you 1, so, and then x plus 3 here, x plus 3 here. When you divide them, they give you 1. So we are left here, remember, it's not 0, it's a 1. So we are left with 1 here and 2 here, and the whole expression is 1 over 2. Now, before I finish, I want to say something very important. One of the common mistakes students make. Remember that this can be simplified dividing by a, because there is a product, there is a multiplication. If it is a sum or a difference or anything else, I cannot do this. I cannot do this because it cannot be proved mathematically. Here we have seen why it's like this, because look, I repeat what I said before. This is like B over C, because I have multiplication multiplied by A over A, because there is a multiplication. This gives me 1, and therefore all this it's B over C. Here you cannot do it. So this is wrong. Always factor before you simplify rational expressions.